Hello, good morning dear students. Today we are going to discuss about pressure. So have you heard about this topic, pressure? You may be heard about BP, blood pressure, isn't it? Your grandmothers or anyway, any of the elder ones may be having this disease, blood pressure. So you may be heard about that one, isn't it? Now we are going to discuss about pressure, the physical applications about pressure. So basically pressure is the force exerted per area. Pressure is equal to force exerted per unit area. So through some examples we can explain this so you will understand it better. See, when you got a nail, ani, and a hammer, and you are asked to put that nail completely into this duster, what you will do? You will give some harm to the nail, isn't it? Just by hitting it hardly. So it will go down easily. What happens if it have no sharp at all? If you got a nail with sharp and if you got a nail without sharp, which will be going more easily? The first one, isn't it? Because it is having very less area and hence it will go downwards easily. So there is a connection between area and force. So if there is less area, we have to apply only less force, isn't it? If there is less area, we have to apply only less force. If the area is more, it is difficult. Even if we give more force, it is difficult to put this nail onto the wood completely. So there is a connection between area and force. This connection between area and force is mathematically represented by a physical equation, that is P is equal to F by A, pressure. The term we use to measure this connection between force and area, that is pressure. Pressure is defined as the force exerted per unit area. What is that? Force exerted per unit area. Wherever you are using per kilogram, per unit area, per length, that means divided by length, divided by area, divided by whatever it is giving after per. So pressure is force exerted per unit area, that means force by area. So if you are giving more force in a less area, what happens? It gives more pressure on the object. That is why if the area is decreased, pressure is increased in a fraction. For example, I will give you two fractions, 10 by 2 and 10 by 5. Which is having more value, 10 by 2 or 10 by 5? 10 by 2, isn't it? What is the value of 10 by 2? Which is equal to 5. 10 by 5 is equal to 2. Which is greater one? 10 by 2. So if the denominator is decreased, the value will be increasing. See, if the denominator is increased, its value decreases. So if we increase the value of denominator, its total value will be increasing. See, here in the equation we got pressure is equal to force by area. So what happens if we decrease area? Pressure will increase. If we decrease the area, pressure will increase. If we decrease the area, pressure will increase. That is why it is going down more easily. Another example. See, you may have seen porters in railway stations or in your own towns or villages. There will be porters. So before taking some weight, they will be putting something, isn't it? Before putting some weight directly on their head, they will be placing some, what it is called in Malayalam, theriga. Isn't it? Why they are placing that one? Because if we are not placing that one, the whole weight will be given in a small area in our head. So it will be exerting more pressure on our head and it is difficult to carry. What happens when we are getting one object in between? See, the total weight that is spread over a large area. If area is increased, pressure will decrease. If area is decreased, pressure will increase. So in the first case, if area is decreased, only if you are placing the weight directly on our head, the area is decreased. At that time, there will be more pressure. If you are placing something above our head and putting that weight on that thing, then what happens? The area is increased. And if area is increased, we will be getting only less pressure. Now one more example. What will be your reaction if you are given a heeled chappal, a chappal with heels, and you are asked to walk on a desert or sandy area? What will be your reaction? It will be very difficult, isn't it? What happens if you have heeled chappal? So its end will be entering into the mud or soil or sand, whatever it is. So in that regions we will be using only flat chappals because the area is more for that. If the area is increased, pressure will decrease. If the area is decreased, pressure will increase. If pressure is increased, our leg will go down the soil or down the sand. So that is the difference between, or that is the connection between area and pressure. What is the connection? They are just inverse to each other. If one is increased, other will decrease. If area is increased, pressure will decrease. If area is decreased, pressure will increase. That is the connection between this force, area and pressure. How? See this equation that was introduced by Pascal, and hence the unit of pressure is Pascal, that you will study in 9th standard. Okay, just remember PA, that is the unit of pressure, and it is in order to honor the scientist Pascal. PA, the full form is Pascal. So that's all for today. Now just go through some of the activities that is given in your textbook. You can see in page number 138. See this activity 11.8. So in this activity you are asked to take two glass rods. Glass rods means that is transparent pipes, just two pipe, and it is made up of glass, transparent glass, and below you have to tie a balloon. So you have to take two glass rods, and just below that, in the bottom portion of that glass rod, you have to tie a balloon. And now you are asked to fill water. So in the first case, you can see it is filled up to a limit only. This next case, the amount of water is increased. What is the difference you can see in between these two pictures? The first one, the balloon is not having enough size. In the second one, the size of the balloon just below the glass rod or the bottom of the glass rod get increased. So when we increase the amount of water, more pressure is applied. See here, that is the example of pressure exerted in liquids. So this water is exerting a pressure on its bottom so that the balloon develops or expands in size. Now here is the second example. In this example, it's not given in the bottom but it's given in the side. Instead of this glass rod, we taken a bottle, a water bottle, and from the side we attach a balloon to the sides. So in this example also we understood that when we increase the amount of water in the bottle, the expansion of the balloon also increases. That is, even the water applies same force in the sides also, not only to the bottom but also to the sides also. That is, force inside a water is spread to everywhere, not only to the bottom but it is spread, or the pressure inside the water is spread into whole regions, to the sides and to the bottom also. And this is applicable to gases also, not only for liquids but for gases also. It appears or it behaves in similar method to the liquids. That is, pressure exerted by a fluid or gas is spread all over uniformly. And now you can see in the third activity that this is just a water bottle and we made 3 holes at the same depth. What you can see is, you can see flowing of water to the same distance. The water will obviously flows through that holes, isn't it? And you can see the water flows with the same speed and to the same to the same length, they flows down. And when we make a hole just above this, you can see there is a slight decrease in the flowing of water. That is, in the same depth, the force or the pressure exerted by the liquids is the same. In the same depth, the pressure exerted by the liquids on its walls in which it is kept is the same. So if it is kept in a bottle, the liquid exerts a pressure in the sides of the bottle, and this pressure is same at its same depth or same height. See here, in this depth, wherever if we make holes in this depth, the pressure exerted by this liquid will be same. But if we make any other hole in somewhere else with a different depth, that means if we make a hole here, just above portion, it will not be as like what is given here. But if we make a hole just below the holes that is already made here, what happens? The water will flow more through them. So to the depths, pressure increases, and in the same depth, the whole holes that is made on the same depth will be having same pressure. They experiences same pressure, but as we go down, pressure increases inside a water. This is demonstrated in activity 11.10. So that is activities 11.8, 11.9 and 11.10. That's all about today. So in the next class we'll be explaining about atmospheric pressure. That is the last topic of this chapter. So now read the chapter very well, go through all the experiments that is given.